How's it going, everyone? Andrew Robinson here, back at it with another Max MSP tutorial. In this video, we are going to talk about some OpenGL objects, namely the jit.gl.gridshape and the jit.gl.mesh, two of my favorite objects in Max MSP. So let's just jump right into it, shall we? First things first, because we're dealing with OpenGL, we have to use the jit.world window. The jit.world window lets us see into a 3D environment. You can't get that with anything else. So we're going to use that, and we're going to set the attributes that I also always set, which is at floating1, at FSA1, and at FS menu bar 0. That's so we have a nice floating window. It's got full screen anti-aliasing turned on, and when we make it full screen, the menu bar is not going to be in the way. We're going to press T, create a toggle, patch it into our jit.world, click the lock icon to lock our patch, click the toggle, turn it on, and you see it change colors because now it is rendering and enabled and we can see into that 3D space. So let's just get right to that. Let's create our jit.gl.gridshape object, and you will see we have plopped down this giant sphere right in the middle of our face. And it's a nice low poly sphere, but we could do a lot to change that. First things first, let's get it out of our face, and we can do that in a few different ways. You can change the position attribute of the grid shape object, super easy, but we can also use this other object called jit.gl.camera, which lets us change the position and other attributes of our camera viewing into this 3D space. So if we just create that and we patch an adder UI into it, which I just created by pressing A on my keyboard, we can lock our patch, click where it says nothing, see there's a whole lot of something, and see that one of those somethings is the position attribute, which by default is 002. So if we just increase our Z value up from 2, we're going to see we're moving the camera further away from our grid shape, which is super cool. Now, here's a cool little feature also that I want to point out. If you highlight over the object so that this yellow triangle pops up, you can click on that, you can click where it says transform, and then you can click change attributes to argument, and that's going to update this object with the attribute settings you just changed. So our position is now set to 004. You could type that in, but clicking the triangle button is easier, especially if you've made a ton of different changes without typing it in yourself. So cool, now that we've got our camera set up at a nice position away from our grid shape object, we can go back to looking at the cool features of jit.gl.gridshape. And the first thing I want to point out is that we can change the shape of the shape with the shape attribute. And by default, we see it is set to sphere, but if we click where it says sphere, and we see there's all these other shapes. There's torus, which is our cool donut shape. There's cylinder, which looks like a circle because we're looking at it from one angle. So we can create this cool object called jit.gl.handle, which lets us click in the window with our mouse and move things around. We can rotate the cylinder that way and see there is a cylinder shape to it. We have open cylinder, same thing, except it's open on the inside. We've got cube, 3D cube, plane, which is just a 2D flat plane, circle, 2D flat circle. Then the last ones are capsule, which is like a rounded cylinder, and cone, which is a pyramid cone shape. And yeah, those are all the shapes that you can change the jit.gl grid shape to. Now, it would be really nice if we could actually see these a little bit more clearly, and we can create another adder UI object by pressing A, patch that into the jit.gl.gridshape, and go down to where it says lighting enabled. You see by default this lighting enabled is turned off, but if we click that on, bam, now we have lighting in our scene and it is interacting with our grid shape object, and we can much more clearly see how this is a 3D object. And you see as I'm rotating it, it's kind of updating because we have a light source over here by default in the jit.world that is hitting it at this angle. I'm going to switch back to sphere just to demonstrate this a little bit better. Yeah, you can see it's brighter over here because that's where the light is hitting it, and we have all these dark shadows on the other side because the light isn't reaching over to that. We can adjust the light just like we did with the GL camera. We just need the jit.gl.light object, and then we could patch into it an adder UI and look at all its cool features, and there are a lot here, and honestly I think I will go over this in a separate tutorial video just because there's so much. But the main one is that there's also a rotate XYZ, which lets us adjust the position of the lighting, and you see by default this is what it's set to get up into that upper corner, but we can rotate this around and you see it is changing where the light is hitting the sphere. If we just set it to 000 for all three, it's going to be centered right on our sphere. Same thing, we're going to click on that triangle, click change attributes to arguments, update it, save it, and that is our light setting for now. So now that we've got that in, we can return to looking at our grid shape attributes and understanding what else is here. And let me tell you, there's still a lot more to go. We can look at the dim message, which would be the next important thing. By default, it's 2020, and that's kind of what gives it this low polyish feel. Before we turned the light on, you could see those jagged edges more. I'll click it off for a second. Yeah, these lines, that's because this sphere doesn't have that many dimensions, so it's just, drawing low poly style. But we can increase our dimension to something like 100 by 100, and look at that. Now our sphere is so smooth. It actually looks like a nice round ball. Even if we click the lighting back off, we're not getting those lines anymore because there's enough points internally in this object to render a nice sphere looking ball. Now what you set these dimension settings to is going to totally depend on your computer and the hardware you've got inside of it and how well your graphics card works. But I have found that by default 100 is like the maximum really you need to go to get that nice smooth value, and you can even do things lower than that. Another pretty sweet feature I've discovered through my years of messing around with these objects is that if we, change just the X value, we're going to take out a lot of dimensions out of our sphere. You see, as we're doing this, it starts to go back to kind of that stretched out, not smooth shape. If we get down really far to 6, you see we only have 5 lines, and we've actually just made a pentagon. We can make it even lower, and you see we've got a square circle shape now. If we're just looking at it from a 2D vantage point, though, it looks pretty square. And if we set it to 4, then we've got a rounded triangle shape, which is pretty cool. So if you needed a 3D triangle, here's how you can make one. You just, give your sphere grid shape object these settings of a dimension 4 by, whatever other dimension points you need to make this look smooth or aesthetic. And that's that. You've got your triangle now. Now it is, as we are showing, a rounded 3D triangle, but that's okay because we have another attribute. That attribute is scale. With scale, we can stretch out the shape of our object in the X, Y, Z dimension. This being the X, so now we've got kind of an isosceles triangle going on. The Y, allowing us to also make an isosceles-ish triangle in that direction or something. But the Z is kind of the one I want to show, because if we decrease this Z to a low value like this, you see it's kind of a much more flat shape. So if you really wanted a flat triangle, this is going to give it to you. It's much more just a simple triangle now, rather than a rounded triangle. That's kind of what I'm trying to point out. And that works with all of these. Here's our flat, cool looking square. Here's our flat, cool looking pentagon. And then, so on and so forth. It's going to be one less than whatever this is set to. So just keep that in mind as you design these shapes. With that, we can look at some other cool things real fast. Not only can we change the shape and the dimension count, but we have this cool attribute called poly mode, which changes how the shape is drawn. If we set this to 1, we get the line look of it, which is pretty fancy. I just really like that. If you set it to 2, it's going to render as dots. Not as fancy, maybe, depending on the object. It could look pretty cool. But yeah, let's just leave that at 1 for now. And that's kind of the main objects to look at in order to create the shaping of your shape. But there's still so much more we have to talk about. We can dive into color next, and if we create another adder UI, you'll see we have things like color. That's an attribute, and it's actually GeoColor, but that's okay. If you click on it, you can then change the color value, so we can turn the opacity all the way up and get this nice crisp white. And then we can adjust this value to change the overall main color of our shape. I'm going to set it something bluish. Yeah, that's pretty cool. So let's talk about jit.gl.mesh. It is another object for creating 3D shapes, except you kind of have to construct this one from the ground up. We've got a matrix in for a vertex array, a matrix in for the text coordinate array, matrix in for our normal array, our color array, specular array. These are all different components of what creates our 3D shapes. But without getting too weedy about it, we don't have to concern ourselves with any of those things actually, because our grid shape object can be used to draw our mesh object as well. It's super easy. First things first, we're going to click this triangle, click transform, change attributes to arguments, and all of these things we just changed are now updated in this grid shape object as well. That is very handy because now we can make other changes to this and it's not going to affect what we just did. I'm going to add at the end a matrix output. By default, it's set to 0, but if we set it to 1, the matrix of our grid shape object is now being output through this. So we have our grid shape in matrix form, which you could do a lot of things with depending on what you're trying to do. Just, some fun technical information. The grid shape in Max is made up of like 12 different matrices, so we are now outputting a list of 12 different matrices. And if we just run this matrix that is our grid shape through a jit.gen object and then out into our jit.gl mesh, you'll see we have redrawn it over here as a mesh now. And it's not got any of these attributes we just messed around with. And that is because the jit.gl mesh is now considered the parent object. So because this is the main object that is now actually drawing the shape and not our grid shape anymore, we have to copy and paste all these things we did over here into this object. And they're actually the same. The only one we don't want to copy is the matrix output. We're going to ignore that one, but the rest we'll just copy and paste over, and then bam, we have now recreated our object the same way that we had it before. You see I'm clicking and turning on it, and the jit.gl.handle is turning, but our shape isn't. Same thing. It's because the grid it's attached to the grid shape and not to the mesh, and the mesh is the main drawing context for this object now. So there we go. If we just patch that over to the jit.gl mesh, it's updating. If you have anything else in your patch that you're trying to work with, maybe a jit.gl material or a jit.gl.multiple, those things would also have to be moved over to this object. Don't worry about that if you're not doing it right now. We're going to talk about it in a future tutorial video as well. But now that we've got that set up, the reason why this is a very cool technique is because we can now send other matrices into our jit.gen object and change the shape of this mesh, which we would not have been able to do just with the GL grid shape object alone. If we double click jit.gen, you'll see this is our default window for jit.gen. We've talked a lot about this in the last couple of tutorial videos. Go watch those first if you haven't. It's going to be very helpful for the rest of these videos. And like I said, all we got to do is pass a matrix into our jit.gen. So let's use a jit.noise object. And I am going to say one float 32, and we'll do something like 7 by 7. Let's change this dim to a 7, yeah. And you'll notice actually that is the one attribute that still is being controlled by the grid shape object. It's because the mesh is drawing the shape from this object's output. So this dim is still affecting the overall shape of the mesh, but because this is the drawing context, the things like color and all that comes after the construction of the shape, and therefore that is why that is being controlled by the jit.gl mesh. So very important to keep that in mind. It's the dim that is still the one thing being controlled by the grid shape, because that's like a pre-construction thing. So with that being said, and this now being set to 7 by 10, we're going to do a 7 by 7 noise matrix, but we're going to pass that through a jit.matrix, also set to 1 float 32, and we're going to upscale it to 100 by 100, because that was like, The reason I'm doing this is because we have 7 in our X, but 100 in our Y. This is going to create a 7 by 7 X and Y, and then upscale that to 100 by 100. I just think that makes kind of a lot of sense in terms of having this affect the entire shape of this without being too much noise. You know, we only want a few jaggedy things here and there. So with that said, we're going to patch that into the gen, and we are going to then send our noise matrix a bang, which will then output it through this patch core into the jit.gen and redraw our shape like this. Now, this this is what our shape looks like with a random noise matrix added to it. I'm going to actually create a P window also. If we click this bang again, we'll see we are getting this one matrix, so it's just black and white, and it's just random values in that 7 by 7 matrix. And so the closer it is to white, that means the closer the value is to 1. So that 1 is being added to the dimension point of this shape, and it's protruding out up because it's having a higher value added to it. If it's a black square, it's closer to 0, so it's going to not change that much and remain close to our original shape. And the other thing is this is on a value between 0 and 1, which our OpenGL world here doesn't work on that same coordinates value. It's -1 to 1. So if we want this, that kind of what I'm trying to say there is, like, no matter what we do, you're gonna see it's kind of gonna add from the center up out, which kind of makes our object look off center. So there are a few different ways you can change that. You could just change the position of the grid shape. We can also, in our jit.gen, add a scale object and scale the range of our noise matrix from 0 to 1 to like -0.5 to +0.5. And we'll patch that out through to this, and that will sort of help center it again back in the middle. And you see, yeah, now it's kind of adding up and down. That's because our black ones are now closer to -5 than 0, and it's actually the perfectly balanced gray ones that are around 0 and not making this change. Now that we've got that, this is why jit.gen is so valuable. It's because we can add all kinds of matrices and effects to change our shape in complex ways and make it do cool things. So if we wanted to animate this now, that is also possible. Let's throw in a jit.world object, and we're going to say bound mode 2, and we're going to say anchor 50, anchor X 50, anchor Y 50. So that way our anchor points are set exactly in the center of our matrix, because our matrix is 100 by 100. Bound mode 2 is the wrap type that it will have. So when this starts to be pushed off the edge, it'll wrap around the other side. And we can see that in action if we attach an adder UI to our jit.rota and click offset X, lock the patch. You can then play with this value and nothing's happening, and that's because actually we need to now send a bang to our matrix to have it output and update the shape. So that's really easy to do because we actually get a bang out of the middle outlet of our jit.world every single frame update. So we can create a send object and call it something like render, patch that middle outlet up to that, and then I'm going to make a copy of this, change the S to an R for the receive, and then patch that into the matrix, so that way that bang is coming out and hitting this with every frame update. And now when we change this value, we'll see it all sort of update and move. And instead of just, manually clicking and dragging this, I want this to be automated. So let's create a jit.time object, which if we have a jit.world render context, will just automatically start outputting values. And we'll see that we can patch that into our offset X to have it update and change this. And it's just a little bit slow. Let's change the speed of this to something bigger. Let's say 3. Let's say 30. That's working. But you know what? I don't actually like that animation as much. Let's try something else. Let's try theta. Let's see what theta does. Okay, now it's too fast. Let's set the speed back to default. Oh yeah, okay, that's really cool. That's the effect we're going for. you see that is a nice smooth rotation. Let's even reduce the speed a little bit. Very cool. So now we get this cool undulating complex shape being animated. And we could stop there essentially. I would just want to see if we can get these matte color materials to actually work the way that was intended. Okay, so I totally forgot about something major. I feel like a dummy not remembering this, but jit.gl.mesh and jit.gl.gridshape have an attribute that is auto material, and this is on by default, and this overrides these settings. So if we click the auto material off, you'll see, bam, now our shape is updated with these colors as well. And that's really how you can get to adjust some of these settings at this level with just these objects. The matte diffuse is still the overarching main color of the thing, although it's kind of hard to see now with all the other stuff we've done to it. There's also matte emission, which you see kind of seems like the main color right now, but it's the internal color that gets emitted out, which we see happening because of the way we've animated this. You see the matte specular is sort of adjusting that one color in that one very tiny section right in the middle, and that's because that's where the light is hitting it. Like it's where the light hits the object and with the color of the light at that point. Yeah, so if you adjust it, it's going to be a very small section that changes. Then we also have the matte ambient, which I don't know if we'll be able to see based on this draw settings. That's okay. That's how you can get to those colors as well. That needed to be pointed out. The auto material has to be turned off. And then once you have all that set up, however you like it, whatever colors you want, again, you can click the triangle, click transform, change attributes to arguments, and now all of that is hard-coded in. And next time you load up this patch, it's going to be ready to go right there. And so that's going to be the end of this video. Thank you so much for watching, you guys. I hope you learned something that you didn't know before. If you did learn something, please remember to like and subscribe, because that's how I know you learned something, and it really means a lot to me when you guys do that. If there's anything that you are still confused about, if you've got any questions, please leave that in the comments down below, and I will do my best to answer them when I can. And on that note, I will see you in the next video. Thanks so much for watching, and sorry about the noise here at the end.